on recording. So the objectives of this chapter number 5 is to give you an idea and explain you about arrays, the methods, which are static methods and non-static methods, right? So we'll see like what are these methods and where we can use these methods, how methods will help us in solving the problems or in programming, right? And then we're gonna see the two ways to pass the values to the references. That is, when we write any method, right, we can pass the values to the methods. So we'll see like what are these two ways to pass the values to the methods. Okay. Then we'll talk about method overloading. What is method overloading? Okay, we will discuss about this. So these are three main objectives of today's discussion. Introduction to the methods. In object-oriented programming, the objects are used as building blocks in developing a program. We have seen that when we write a C# program, it's a class, right? So in object-oriented programming, we write the classes. Inside the classes, we write the methods. Like we wrote the methods, we have the method, the main method, right, which is a static method. Similarly, we can write our own methods. We can write a method to add two numbers. We can write a method to multiply numbers. We can write a separate method to find the area of circle, find the area of square or a rectangle, and so on, right? So when these methods are created inside a class, and if we want to use these methods outside the class, we create objects of the class. We create objects of the class. And once we create objects of the class, we can call these methods. Yeah, do you have any question? The screen is shared. How about the other students? Can you see the screen?
Yes, we can't see the screen.
Yeah, we are in introduction slide. Can you see that introduction slide? Right? So Amna, can you just please re-log in? I mean, I think you have problem from your side. Okay, fine. So, so we can create the methods and we can call these methods wherever necessary to make use of those methods, right? So objects can be created to make use of these methods, but for now we try to understand what is a method, and we are not going to look inside the objects like how we create the objects or how we are going to deal the objects with the objects. Fine. So now when we create these objects, right, object encapsulates data and code to manipulate these data, and the code is designed to work on data, which is known as methods in C#. That is, whatever the code we are gonna write to work on the data of the class, right? For example, let's say that we write a class called a student, and the student has some data, right? For example, student ID, student number, student name, student email, and student marks, courses, and so on. And we write different methods in this student class for different purposes. We may write a registration method, we may write an calculate GPA method, and so on. So when we create objects of the student class, for example, student Ahmad. So we create an object of Ahmad. Ahmad has its own data of ID, name, email, courses, GPA, and so on. And Ahmad can call the methods like registration, calculate GPA, for example, print the transcript, these methods. Similarly, when there is another object, another student, for example, Abdullah. Abdullah is an object now, which is a student object, has its own data. And Abdullah can call these methods, registration, calculate GPA, print transcript, and so on. So these methods work on the data. For example, to calculate GPA, the method GPA takes the student registrations in the courses, their score, and calculate the GPA. Right? So the codes are written in a methods for every action, for every task. Right? So we can divide the task by the methods. We can divide the tasks by the methods. Okay. So method gives object their behavioral characteristic. That means method helps the objects to do some task, to do some job. They are used not only to access and process data, but also to provide some response to any message, any other messages received from the other objects. A method is a group of statements that together performs, and in every C# program we have at least one method, which is the main method. So that we have seen that before, that every C# program, for example, here I have the main method, right? So every C# program comes with this main method. Main method is the one where we start the execution of the program. Okay. C# is pure object-oriented language, and therefore method must be contained within a class. The main method must be within a class. Now, declaring methods in C#. Declaring a method inside a body of the class, the general form is that you write the access modifier, the return type of the method, the name of the method, and the parameters, the formal parameters of the method, and you open the bracket and close, and that forms the body of the method. So if we look back here, we have the access, we have this the static void main, the arguments, and this becomes the body of the method. Okay. Apart from that, we can also mention the access modifier. Now, what are these access modifiers and why we need these access modifiers? Access modifiers help us to define what permission we have to access these methods. Some methods are public in the sense we can call these methods anywhere from the class. If the methods are public, these are public method in the sense you can call these methods from anywhere. Some methods are private. These methods work only inside the class where you write these methods, where you declare and define these methods. Whereas public methods can be accessed outside the class, anywhere you can access. Once you create an object of that method outside the class, the object of the class outside the one class, you can access the methods. We also have something called protected and internal. Protected is you can access a method within a class and its subclasses when it comes to inheritance. In the sense, a class can have its subclass. It's like father and child. So a father class can have a child class. So a superclass can have a subclass. Now, if there is a method in the superclass, we can access this method in the subclass if it is protected. If it is private, no, we cannot access. If it is public or protected, we can access. And internal, within the assembly of the class, within that project of the class, we can access the methods which is defined as internal. So first word in defining the method is the access specifier or the access modifier, whether it is public, private, protected, or internet or the internal. Okay, so this is the first part or in the method header. This is what we call it as a method header. Okay, which we have access modifiers. So access modifiers can be public, private, protected, internal. Basically, we use public when we want the methods to be accessed from anywhere. Sometimes we use private when we want to keep a method private and within the class itself, and we don't want anyone to access this method outside the class, whether by creating the object or not creating the object. Sometimes we want to keep them protected so that it will come only in the class hierarchy, father and child class and so on. That is the super class and subclass. And sometimes we want to keep internal to be accessed within the project. So this is what is an access modifier, right? The first thing. Then we have a return type. Return type is a method may return a value. If a method is returning a value, know what type of value it is returning, whether it is returning an integer value or a float value or a double value or a string value or a character value or a boolean value, what type of value the method is going to return, that we have to specify. And we can see that in our method, in the main method, it is said void. Void, it means the method does not return any method. You don't see any return here. Right? You don't see any return here. So that means that this method does not return any value. But when we have some return type, for example, integer as a return type, this method must return some value. You can see that program main, not all core paths return a value. That means this method is not returning a value. Now I have to return some integer value, for example, return 0. Now it's okay to write int and we have a return an integer value whether it is 0. Okay, and what if my method does not return any value, I just mention void saying that this method does not return any value. It executes when we call this method, but it does not return any value. That's what it means here. So return type can be any data type here, for example int, double, or it can be a void in case that your method does not return any value. Then comes the name of the method. This should be a unique and it is case sensitive. You have to take care that the method what case you are using, the same case you have to use when you call the method, when we use this method. Okay, it cannot be same as any identifier declared in the class. For example, you declare a variable sum and you cannot write the same sum in the name of the method, right? Because you already used that sum for another purpose. So sign and try to keep the method name meaningful names. For example, you are writing a method to calculate area of circle, right? So what do you name this method? You name it area. So area of what? So you can name it like area of circle. Okay, one word without any space. Or you can name like area underscore circle, right? So or area to circle, something which is meaningful. When we see the name of the method, we can understand that what does it happen, what does it do. Okay, this is a recommendation, right? Recommendation for a good programming skill, that you use the names of the identifiers which are meaningful names for the variables, for the names of the methods, for the classes and all. Okay, so method name is again a unique identifier to identify the methods and to call these methods. We use the name of the method. Whenever we want to call a method, we are going to use the name of the method to call these method. Okay. Then we have a formal parameter list enclosed between parentheses. Now these parameter list are used here to pass any value to the method when we call the method. For example, we want to write a method called to find the area of circle. Now what we want to find the area of circle, we want the radius, and we want to pass this radius from the main method to the area calculate area method as a value. Then we can write that here as a parameter, that this parameter takes a value, okay, and these values are taken into the method inside the body of the method and performs the calculations, whatever. So the parameter list refers the type, order, and number of parameters of a method. So you have to specify in order. For example, if you have more than one parameter, it cannot be, it is not necessarily like it is only one parameter. It can have more than one parameter, or sometimes we can have no parameters, zero parameters, right? And we can have different types of parameters. We can have integer, we can have characters, we can have strings, we can have arrays, okay? Different types of parameters we can have, and different numbers we can have. For example, 2 parameters, 3 parameters, and not necessarily that all parameters should be the same type, all should be int. No, can be all int, it can be one int, one double, one float. It depends on what is the requirement of the method body that needs to perform the operation. Based on that, we are going to specify the parameter list. And when we call the method, and we are going to pass these values to the method as a parameters, as in parameters, okay? So we also see that there is a main has a string array parameter. You see this is a parameter, okay, of type of his name is argument. It is of type string and it's an array argument, right? Array parameter, right? So in this we can specify different type. When we write our own methods, we can write different type of parameters, okay? In case you don't have any parameter, you don't have any value to pass to the method, right? So in that case you can leave them blank. It can be with no parameters, okay? And finally, the method body that contains the instructions needed to complete the required activity, which is over here within these parentheses. We are going to write the code that is going to perform this method, the action to be taken by this method, okay? Now we have some example here. For example, you see this method, we have an access specifier public, return type void, the name of the method display with no parameters. And what does it do? It just display a message called welcome. Fine. So it's very simple. So I can write this method over here, for example. So let's say that it's a public method. Public does not return any value, and its name is called display, right? And what does it do? It just write a message, welcome to methods in C#. This is a method now called display that can be accessed by creating the object of this class program. By creating the object of this class program. Now what if I want to access this method without creating the object? And I have to make this method as a static method. A static will come in the coming slides. We'll see what are these static methods. Now public int product with parameters. So this is an access specifier, the return type, the name of the method. It has two parameters of type integer. It must return an integer value. What can be the integer value? For example, the product of two numbers. The name says product. It means we can have product of these two numbers and return this product. Okay. This is another method. Public int product or int x comma int y, the product of two numbers. All right. So I'll say int m is equal to x by y and return m. I'm returning this m. Okay. Now you see that this is a method. This is an access specifier, return type, name, parameter, its code. Return some value, right? Now, access modifiers, commonly used access modifiers are public, protected, and private. Right? Public, it means you can access the method from anywhere, including outside the class. Just create the object of the class and you can access the methods. Protected, which the methods can be accessed inside the class and its subclasses. The children classes of the class where you write the method. Okay, this comes in the inheritance. Then private comes the method only, which is accessed only inside that class and not outside that class. Okay, so you can make the methods private. For example, this display is in public method, right? So I'll make it private. You can make it private. Okay, now this method is only accessible inside this class and it is not accessible outside the class program. Okay. Invoking the methods, how we can call these methods in our program. Now here, when we write these methods, right? Now, if I run this program, since main method does not have any code, you don't have any output. So if I run this program, right, I don't have any output. Why? There is nothing in the main method. The program execution starts from the main method, and inside the main method there is nothing. When there is nothing in the main method, you don't get anything, right? What if I have in the main method, for example, console.writeLine welcome. I'll just have welcome as an output, right? Okay, what about these methods? Are they running? They are not executed. Of course, they are compiled, okay, but they are not executed. Why? Because these methods need a call, need an invoke, we need to make a call to these methods from the main method. We need to make a call to these methods, or at least some method must call these methods, which in turn must be called inside this method, inside the main method, so that we will call them and they'll do whatever the job is and we get the result. This is what we call it as an invoking methods. Okay, so the process of activating a method is what we call it as an invoking a method or calling a method. And this is done by using a dot operator along with the object name, the name of the object name of the class, object name dot method name with a parameter list. So in case, like if I want to use these methods, for example, I want to call these method display. Okay, and I just simply say display. It's an error. It shows the name display does not exist in the current context. Okay, can I use the product of, let's say, 10, 20? It says our object reference is required to a non-static method, right? So I cannot use them. So how we can use them is, one way is that we can need to create an object of this program class. Our class is program, right? So program P is equal to new program. This is how we create an object, and I'll say that, okay, P dot display, and I can call P dot product. Now it is fine. This will work, right? Now when I run this, I have the output welcome to the methods in C#, which is from display. The first method to execute is display. So welcome to C#. The second method to execute is product. Now, when we call this with 10, 20, 10 is passed to the X and 20 to Y, and then it is multiplied 10 by 20, 200, returns 200 here. So here comes the 200, but it is not printed on the screen because we did not print that, or we did not catch that return value into any variable and print it, right? So what we can do is that we can either take a result variable, okay, and print that result variable as console.writeLine of the result. Okay, this is one way we can do that. That's fine, we will get that product here. Okay, other way is that we can simply directly instead of storing, we'll just say here p.product. So whatever the value comes here will be here and it will be printed by writeLine. Okay, now when we use these different things is that when we want to store these value, the return value, into a variable and perform other calculations to check the return value, to check what is the result, or to perform any other, we can simply take that into a variable, for example int result, okay, as a p.product of 10, 20, and we want to perform some other thing, for example increment the result or decrement the result or use the result for other calculations, we can do like this. Or if you're just simply printing the result which is returned, we can directly print it by this writeLine. Okay, both the ways possible. So fine, so we use an object name here, right, dot the name of the method, okay, to call the method.
I have a question.
Yes, please.
To the program.
Yeah, please.
In the screen, go back to the program. Yes, so just I didn't understand. So if we write like 2 or 3 methods, and we want to display them, we will display them in the main method, right?
Yeah, we call them in the main method.
The calling, I didn't understand it. Will this program be equal a new program?
Calling the main method, you mean you did not understand calling?
The calling is why did we write program B equal a new program? This is the line.
This line is what we call the object creation. As I said, we write the programs here. These are the classes. We see that class program. Fine. Now, when we write these methods, these are non-static methods. It's not like a main method as a static method. We don't have a static keyword here. And if you recall the first meeting or in the second meeting, when we saw the first program, we said it's static. It means we don't need any object to call these methods, static methods. Fine. So we don't have a static method here. These are all non-static methods. For any non-static method, whether it is in Java or it is in C#, when we want to call these methods, we need to create object of the class. How we create an object of the class is by this. The name of the class, the name of the object is equal to new program. This is called constructor. You will see, I think, this in chapter number 7, moving ahead. And even in this, we'll see at the end how we create the constructors. Okay, this is called constructor. This is called creating an object. We need to create an object of the class to use its methods. In the sense, if these methods are not static, if they are static, we don't need the object. For an instance, let's say that I'll make this method as static. Okay. Now you see here it is a static method, right? We don't need the object here. I can simply call these methods without using an object, and it works, right? And what about the product? Product is non-static method. I need this object to call this method. Okay, so this is the difference. And when we want to access any method which is not static, we need to create an object of the class in which the method exists by this way, and then we can call the non-static method. And in case of a static method, you can simply call them by the class within the class without creating an object of the method. I hope it's clear now.
Yes, it's clear. Thank you.
Fine. So these are how we define. For an instance here, you can see we have a method called cube, right? And within a class called method. Fine. So you see this is one separate class where we have a method method called cube, and it is non-static. This returns the cube of the value. Value is multiplied by 3 times, and it returns that value. In another class, in the main method of it, if I want to use this method, what I have to do is that I have to create an object of this method class by this method m. The name of the object is equal to new method with these brackets. This is called constructor to create this object. Okay, this is more like creating a variable int x is equal to 10, right? But here we need to use the new that constructor just to assign memory to this object. Now using this object m, I can call these methods. So I say that m dot cube of 5, this will call this method cube with the value 5. 5 is multiplied 3 times, and it returns that value here. It will be stored in y, and y is returned, which is the output will be displayed 125. Okay, so here it is the method call. Here we create an object. Here we call the method and store the result in a variable, and then we print the result here. Okay, this is how we invoke the methods. Now, in case we don't want to use the object and we just want to have a static methods in our class, then we need to add this static keyword after the access specifier. These are more same like your main method or a write line method. These are all class methods. When we write this console.writeLine, console is a class, right? You can see it is a class from system, right? And this console has this write line method. So this write line method is a static method. It is a static method because it is invoked by using the class and not by object. We are not creating object of console. No, we are directly using the console, the name of the class, and dot the name of the object. Okay. So similarly, if you add any method as a static method, for example, here I make this product as a static. I don't need this p now. This object I don't need because all my methods are static. I can simply call these methods without creating any object, without the need of the object, because these are all my static methods. So I can run them, it's fine for me now to work. Okay. So when we create an object is that when we have a method that is non-static method, we need to create an object and then we can call them. Okay. Fine. We also similarly, we can also have these variables as a static and non-static variables. If a variable is a static, you simply use this variable in the main method or in any method because it is a static and it is shared by all objects. The same copy 20 will be there for p as 20 for every object of the class, and everywhere you'll find that whatever the value you have for that variable, you will get that. What is the latest update of this variable? You will have that because it is static. When in case of a, which is non-static variable, this variable has to be with the object. The class is test. We create test t1 is equal to new test. T1 is an object. T1.a is equal to 10. So T1 object has a variable 10 with the value, has a variable a with the value 10. So it gets to, if I create, what if I create T2, for example? So if I create test T2, or let me show you here practically. In the sense, for example, I create here int a, and I create here a static int b. Okay. Now in my main method, I create an object called p. Okay. Forget about display and all. And now, if I want to use a and b, a must be used with the p because it is a non-static variable. Okay. So if I want to write the, update the a value, I can say that a is equal to 10. Sorry. A is equal to 10. Right. It gives me an error. It says an object reference is required to the non-static field, which is a variable, right? So I have to use p here, p.a. It works fine for me. Okay. And what about b? For example, b is equal to 20. It's fine because it is in static. Okay. So let us just print now console.writeLine of, I want to print the a and b. Okay. And a and so a should be with p.a. Okay. So it works for me 10 and 20. Okay. Fine. Yes.
As a programmer, why would I use private or public methods? I will use only static. It will be easier for me.
Okay. Now static, whenever we create, see, object creating is not every time we have a single object. For an example, let's say that we write a class called a student. As a programmer, you are in a programmer team. I mean programming team where in the development team where you are a programmer and you have a task of writing the SIS software, okay, or developing the SIS software. Now there is a class called a student that you need to write, and there is number of operations you have to do with the student class, and a student has a number of data. It has an ID, email, and name, and national ID, and so on. What do you think? Like how you store these? Every different student. Let's say, for example, in KSA we have 10,000 students. How do you create objects of this? And when we write a class, we write in common a class student, and we define the common variables for every student: ID, name, national ID, passport number, for example, email, and so and so and so. And we define a number of methods which are common to every student: registration method, add and drop course method, add course, drop course, calculate GPA, or all other different methods, right? When we do this, for example, we need to keep some methods private inside the class because we don't want these methods to be accessed outside the class. Because, for example, let's say that we have a method called in the inner class method. We don't want this to be accessed outside the class. We'll keep them private. For example, calculate the semester GPA. Semester GPA should not, let's say that we don't want this method outside the class, we'll keep them private. Number one. Number two, we have 10,000 students, right? Every student has its own ID, everything is its own, right? Your ID is not same as other student ID. We have to keep them every student different ID. We have to keep every student has different name, every student has different national ID, and so on and so. Now, in this case, what do you think that we need? Can we store that in one ID, all these IDs? We cannot. Every student now acts as an object. Every student here is an object. In the sense, for example, yourself is an object. You have your ID, you have your XYZ. Another student, for example, let's say Ahmed is an object. Abdullah is an object. Abdurrahman is an object. Abdullah has its own data, Abdurrahman has its own data, everyone has its own data. For example, let's say that here I create another object, program P1 is equal to new program. Now P1.a is equal to 20. What do you think? P.a and P1.a, they are different or same?
Different because
They are different. P is a different object, P1 is a different object. You as a student, a different object. Your friend, for example, Ahmed is a different object, has its own, right? So that's why when we write any class, right, as a programmer, when we write any class, we write that as common. And from this class, we create objects of it. So we have a student class, right? And from this student class, we create every student. We can create 1,000, 10,000, 1,000, 1,000,000, 1,000,000,000 objects, no matter. Every object must take a different value. So by creating the object, we assign them these variables, we assign them these methods, and we work with that. So we'll see that here, for example, let's say that P.a is 10, P1.a is 20. Now if I say P1.a, what I will get? I'll get 20, right? Not 10. So that means more specific. So that's why we need to have something like this, where we create the objects, where we write different methods to work on these objects, and then we'll we'll create objects of these classes and make use of these objects as an instance of a class to work with that objects. Okay, this is why we need all these kind of thing.
Okay, thank you.
Okay, since we are at the beginning of the programming, so we are, yeah, it might be we think like why we need this, why we need that, but these are used when we write big programs. Okay, so we have to give you the concepts here at the beginning, right? So that you will be okay with coming programs, right? If you go advanced in this, you will be okay with that. Okay. So this is what the difference between a static and non-static variables or methods. Okay, static, it means we can access them within a class without creating an object, whereas non-static we need to create an object. Okay, for an instance, we have a static method called product here that returns a product of two numbers, right? So we don't need to create an object of it, object of the class. Simply we just use the name and we call that. Okay. Similarly, we have a static square method, takes a square of it takes a float variable, float value, and print the square, return the square. We can simply print the square of the numbers. Okay. Now here we have some examples. Create a function called static function called add that accept two numbers from the user and print the sum. Now this function takes the values, right? Calculate the sum and print the sum. Everything is done inside the function only, right? So how we write it is simply we declare the variables, static variables, number one, number two, and result. We write the method public static void. Why void? Because this method is not returning anything, right? So we use void. We call there is no parameters because we are going to ask the user to enter the values, right? So there is no parameters here. Now the method body is like this. enter the number 1, we read the first number, enter the second number, we read the second number, calculate the sum, print the sum. This method is closed here. Fine, the method is okay. Now how I invoke this method? Since it is a static, I don't need to create any object of this class. Simply I use the name of the method. In my main method, I just say add. This will invoke this method and it starts the execution from here, asking you to enter the first number. You enter the first number, then it will ask you the second number, enter the second number. Let's add these two numbers. It will give you the result sum. When if this 73, I think, yeah, 73 will be printed. Sum is equal to 70. And the method finishes its job. It comes here and see there is no more code. The program is gonna terminate here. Okay. Similarly, we have another example here, static function big that accept two numbers from the user and print the biggest of two numbers. The same thing, just read these two numbers, check the number 1 is bigger than number 2, print the biggest number is number 1, else biggest number is 2, else both are equal, finish. How we invoke in the main method, we call big. The big is will call this. It will ask you to enter these two numbers. You enter these two numbers, then it will check the first number is greater than number 2. If it is true, it will print number 1 is bigger. Done. And it will come to the main. There is no more code to execute. Will terminate the program. Okay, simple. Now, the next thing here is something called pass by value and pass by reference. We have seen these examples here, right? The static methods and all, how we create the non-static and the static methods and non-static static variables. Okay. Now let us understand the new concept here called pass by value and pass by reference. What is this pass by value and pass by reference? When we call these method which has some parameters, you see these parameters. When we call these methods, we are going to pass the values to these methods. Okay. Now, for example, let's say that I have two variables here. Int number 1 is equal to 10, number 2 is equal to 20. Okay. Now, I'll write a method here called public static swap of int x comma int y. So what is this method is going to do is that it will swap the two values x to y and y to x. So I'll take int t as x and I'll say x is equal to y and then I'll say y is equal to t. Okay, the swapping is done. Fine. Now I'll call this swap method from here swap of. Now let me print the first console dot write line. What is my n1? Number 1 is equal to the first value, comma number 2 is equal to the second value. Okay, n1 comma n2. Fine. So what is the output of this program now? It will just display me n1 and n2, right? n1 10, n2 20. That's okay. Now let me call swap of n1 comma n2. n1 is 10, n2 is 20. We'll call this swap method and we'll pass here 10 and 20 to xy. Now we are going to swap this xy here, right? After the swapping, I want to check again the n1 and n2 whether they are swapped or not. What do you think? It will be swapped or not?
Yes.
Swapped? It will be swapped, right? Should be swapped, huh? Yeah, there is a magic here. It is not. It will not be swapped. It will be same. Why? This is what we call pass by value. Pass by value in the sense when we call the method and we pass the values to the method, it takes the copy of n1 and n2. n1 is taken here, n2 is taken. What it means, 10 is given to x, 20 is given to y, and swapping is done here. If I print here x and y, console.writeLine of x is equal to the value, just take this. And this is y, and this is for x, and this is for y. Okay, and this is inside the method in swap method. What is x and y? Okay, and then after swap, here after calling swap, you can see here now there is some error here. Input string was not in a correct format. Okay, stop this. Now, n is 10, 20 initially. In swap method, x20 and y10, there is a swap. After calling swap, n remains same. What does it mean? It means that it takes the copy of 10 and 20 here to x and y. Swap happens inside the method, but it does not affect the value of n1 and n2 because it is what we call it as an pass by value, where we are going to pass the value of the formal parameter can be changed within the method, but the value of the actual parameter passed by value to a method is not changed by any changes made in the corresponding formal. Actual parameters are these when we call this swap, right? This is the actual parameters and these are the formal parameters. So value will be given to x and y, and whatever you do inside the method will do only to these and will not affect this. This is what we call pass by value, right? Clear? Is it clear? Before I go to pass by reference, students, is it clear or?
Yes,
Okay, fine, great. Now, pass by reference, what we want this to be in opposite. I want this, whatever I make the change to be happened here, then I can do it by using something called a reference, the reference of the variables. What is this reference of the variables? This is, we are passing the reference here. You can see I have to use ref as a reference. I am passing the reference of n1 and n2. It is not I am copying the values. No, I am passing the reference where the values are present in the memory, right? Now you can see that n1 and n2 is also swapped. You can see n1 is 20 and n2 is 10. This is what we call pass by reference. So what happens in pass by reference is that, for example, this is the memory where I declare two variables, right? N1 and N2. So N1 is this, N2 is this, 10, 20. Okay. When I call swap of N1 comma N2 without reference, what happens? What is the value of N1? 10, 20. We'll go to the swap method. Let's say here we have that swap method. Okay, it takes int x comma y, int y. So 10 and 20, 10 here, 20 here. You do whatever you want in the swap method, will not affect N1 and N2 because you are doing for x and y. X and y is somewhere here, for example, x and y, 10, 20. So whatever you do swap will be affected here, and this remains same. Right? This is in pass by value. Now what is in pass by reference? In pass by reference, when I say swap of reference of N1 comma reference of N2, I am giving the reference of the memory where the values are stored. When I call this, when I have this swap method here with int x, reference int x and reference integer y, I'm giving the reference here. So that means x is referring to the N1 value here in the memory, y is referring to the N2 value in the memory. Whatever the change I make for x and y will affect here. If I make a swap here, will affect 20 and 10. This is also affecting to N1 and N2. Okay, this is what we call it as in pass by reference. This is what is happening here. Pass by reference. Okay, so these are two concepts we have in methods, pass by value and pass by reference. So we are going to use this reference here. Okay, for example, this example, changing the m, x value is 100, change, we call the change with the reference of x. We'll take to the m, add 10 to the 100. Okay, and when we print x, we get 110. Why? Because it is changed, 10 is added here, and we call them as pass by reference. Okay, so swapping, yeah, here it is a swapping method, what I just explained you, right? So with a reference. Okay, this is what we call pass by reference. So is it clear, pass by reference and pass by value? Is it clear?
Yes, clear.
Okay, moving ahead to another concept of in methods, which is called method overloading. Now this method overloading help us in writing methods, similar methods with the same name, okay, but with different parameters. For example, let's say that you want to write a method called volume, volume of a cube, volume of a cylinder, volume of a box. Volume of cube is different, volume of float, sorry, the cylinder is different, volume of a box is different. Okay. Similarly, if you want to say, for example, you want to write a methods to calculate the area of a geometric shape, area of circle, area of rectangle, area of triangle. Okay. In that case, every area takes different parameter. Area of circle takes radius, area of rectangle takes length into width, length and width, or height and width, right? So the same name but takes different parameters. This option allows for this we have an option, or we can say a facility in programming called method overloading. we can write similar methods with the same name, but with different parameters. The parameters should be different. We can see here this volume method has only one parameter. This volume method has two parameters, and the third volume method has three parameters. Now, when we call these methods, how these methods are differentiating? If I call the volume with only one integer value, this will go and check where is that integer value method. It's here. It will call this and execute this and return cube of a number here. This returns a cube of a number here. If I call this with one float value, the other integer value, volume with 2.5 float and integer, this will go and check where is this. It's here. No, it's here. Yes, it is here. Giving this 2.5 to R and 8 to the H, and calculate this volume and return the volume to print here. When I call this with three values, one with a long integer value, the other is an integer, the third is an integer, it will go and check where it is. It is here. Yes, 100 is given to L, 75 to B, 15 to H, multiply all of them and return the volume here. Print it. Okay. So the mapping is done based on the number of parameters and the type of parameters we have. Okay. So this way we can write methods with the same name but different parameter list, and the invoking of the method depends on the number of parameters and the type of parameters and how they are arranged or how they are added. This is called method overloading in programming. Okay. So we have another example here. Overloading the sum method. Sum with no parameters, sum with two parameters of type integer, sum with two parameters of type float, sum with a string. Okay, so we have four methods with the same name: public static void sum, public static void sum, public static void sum, public static void sum. But their parameters, one has no parameters, the other has two integer parameters, the third has two float parameters, the fourth has one string argument, string parameter. Okay, same name, different parameters. This is what we call method overloading. Now, when we invoke these methods, the mapping is done based on the parameters. For example, if I call sum with no parameters, this will be invoked, and what it writes, no value provided on the screen. If I call sum of 5, 4, 5 and 4 is integer values and not float, right? So 5 and 4 integer will go for this x5, y4, 5 plus 4, 9, you will get the output. If I call this with float value 9.3 f, 8.6 f, f means float, this will invoke this float with x 9.3, y 8.6, sum of them printed here. When I call sum of hello world is a string, right? So it will go for this string. It's not a numeric value, it will be printed. Okay. So the invoking or the mapping is done based on the parameters list, and this is called method overloading. Okay. The next is the constructor concept. C# provides a special type method called constructor that enables an object to initialize to itself when it is created. Is that constructor I created here? Program P is equal to new program. This is what is called constructor. Constructors are used to create the objects and to initialize the objects, to initialize its object values. Constructors are more like similar, like we can write them like methods, like for example public program. Okay, this is my constructor. Okay. These constructors are used to construct the objects, to create the objects, and to initialize the value. For example, let's say that a is equal to 10. Okay. When I create p, the a value, let me write this console dot write line p dot a. When I create an object p here by calling this constructor, this will call this constructor and set the a value to 10 for p. So p dot a will get 10. Okay. 11, for example, p dot a will be 11. So this will be the initial value for any object will be created by using this constructor. This is what we call constructors. These are more like methods having same name as class name and does not have any return type. They are not static and does not have return type because constructor never returns any value. So that's why there does not have the return type. Constructor have same name as the class name, which is program. The class is program. Secondly, they do not specify return type, not even void, because they do not return any value. Okay, constructors are created by like this. Okay, this is just to test that object is created. When we create an object, you can test that when the p is created, this constructor is invoked. Constructor is invoked. So you can see here constructor is invoked and then we have the p value, sorry, the a value for p, right? Any number of constructor you create, for example, you create p, right? Here I want to create p1, p2, p3 like this. For example, I create here p1. Okay. I'm not printing here, let's say. Your two constructors are created, p and p1. Okay, both p and p1 will get this a value as 11, the initial value. This is what is called the initial value for the variables. Later, p1 can change the a value and p can change a value. Okay. We also have something called destructor to destroy the object. This destructor is same as constructor but preceded with a tilde operator, which is like this. This is to destroy the object. When we call the destructor, it will just simply delete that object. Okay. More about constructor and destructor will be covered in unit number 6, will be in the next class. Fine. So this is all what we have for you in this chapter 5 called methods. So we saw here how we write the methods, how we invoke the methods or call the methods, the static and non-static methods, passing parameters to the methods, two ways, pass by value, pass by reference. Then we saw method overloading, and we just read about constructor and destructor. So this is all what we have for you in this method chapter number 5. Okay. Any questions? Please go ahead before we move to the chapter number 6. Any questions?